Hey there! Welcome to my channel. I'm a QA engineer with 10 years of experience, and my programming ride has mostly been with Java. I'm here to spill all the Java secrets I've gathered along the way. Practice is a big deal in programming, but let's not forget the importance of wrapping our heads around the theory. In my first video, we're diving deep into the world of Java and its components. Let's start to explain, what is Java? Java is a versatile and widely used object-oriented programming language known for its platform independence, thanks to the write once, run anywhere principle. Java emphasizes readability and simplicity. In here, we see Java architecture and components. This hierarchy represents the process of developing and running a Java program. At the top of the hierarchy is the source code. This is the human-readable code that you write to create a Java program. It consists of classes, methods, variables, and other programming constructs that define the behavior of your application. The Java Development Kit is the next level in the hierarchy. It is a software development kit that provides tools and utilities for developing Java applications. The JDK includes a compiler to translate your source code into bytecode, as well as other tools for debugging, documentation generation, and more. The JDK, in turn, includes the Java Runtime Environment. The JRE contains the Java virtual machine, along with essential libraries and components needed to run Java applications. The JVM is responsible for executing Java bytecode, which is the compiled form of your source code. Lastly is the operating system. The JVM interacts with the operating system to execute the Java program. It abstracts the underlying hardware and provides a platform-independent execution environment for Java applications. Let's summarize. The flow of execution in a Java program follows this hierarchy. Source code is compiled using the JDK, resulting in bytecode. The JRE, which includes the JVM, then interprets or compiles this bytecode into machine code that is specific to the underlying operating system. The operating system finally executes the machine code. This hierarchy ensures that Java programs can be developed on any system with the JDK, and the resulting bytecode can run on any system with a compatible JRE and JVM, maintaining the platform independence that Java is known for. In this graphic, I illustrate the structure of a Java program. Project. In Java, a project is a collection of source files and resources organized for a specific purpose. It could be a standalone application, a web application, or any other software project. Package. A package is a way to organize related classes and interfaces in Java. It helps in avoiding naming conflicts and provides a structured way to manage your code. Packages are used to group related classes together. Class. A class is a fundamental building block in Java. It is a blueprint for creating objects. Inside a class, you define methods and variables that represent the behavior and state of objects created from that class. Methods and variables. Methods. These are functions defined within a class that perform specific tasks. Methods represent the behavior of objects created from the class. They encapsulate the functionality of the class. Variables. Variables are used to store data within a class. They represent the state of objects created from the class. Variables can be fields or local variables. So, the structure I've outlined reflects the natural hierarchy of a Java program. Projects contain packages, packages contain classes, and classes contain methods and variables. This hierarchical organization is essential for creating modular, maintainable, and scalable Java applications. Please remember that practice is key in programming. As you encounter challenges, refer to documentation, forums, or tutorials. This hands-on approach will deepen your understanding of Java and help solidify your theoretical knowledge. We are going to be installing Java in the next video.